This is Food Chem Unit 4, continuing our discussion of the nutrients in our foods. So here we're going to focus on phytochemicals, which are referred to as the other food component. Phytochemicals or phytonutrients are compounds originally produced by plants. Phyto is the Greek word for plants. These compounds seem to help plants endure extreme weather, fight off disease, and often resist pests. They're found naturally in vegetables, fruits, grains, herbs, and spices. They give foods their colors and flavors. The first group we're going to focus on are the allyl sulfides. This is basically a liquid in the plants that has a strong odor. It contains sulfur, the symbol of which is S, that's an element on the periodic table. These will increase enzyme reactions. Enzyme reactions with these can help rid the body of carcinogens, which can cause cancer. There's evidence they kill bacteria, fungi, and viruses. They are found in onions, garlic, leeks, and chives. Garlic allyl sulfides have blood-thinning properties like aspirin. Cooking, however, will change the allyl sulfides, so it's best to eat these foods raw to get their full effects. Carotenoids. These are basically pigments that plants make. They are antioxidants, which means they reduce tissue damage that can lead to the formation of cancer cells. They enhance the immune function and help maintain healthy eye tissue and reduce risk for cataracts and night blindness. Examples are carotenes, and these are pigments in the following foods. So two examples are alpha carotene, which is that bright orange color in pumpkins and carrots. Beta carotene is the dark green and yellow color in those types of vegetables, like kale or like yellow peppers. Flavonoids. These are basically compounds responsible for many flavor characteristics of food. They're also colored pigments, and most are red and white. There's over 800 possible health benefits. And just note that I do say possible. It's really possible health benefits for all of these. It depends on your metabolism, just your own body, and the rest of your diet. I'm just listing possible health benefits for all of these phytonutrients. Isoflavones. This is mainly in soy products. So people who have a soy diet have a possible lower risk for many cancers. Now, soy itself is found in chickpeas, licorice, Chinese cabbage, and bok choy. Food scientists will use these in place of many animal-based proteins for people who choose not to eat meat. It's relatively tasteless, but it's healthy. And you can decide for yourself. I will post this video about whether soy is good or bad in Schoology if you'd like to watch it. All right, so let's talk about phytochemicals and food processing. So if you'd like to maintain the color of foods, if the color of a food is maintained, the phytochemical is maintained along with that phytochemical's health benefit. So the more you leave these foods raw and keep that bright color with it, the more you benefit from that phytochemical. There's nothing wrong with cooking foods. It's just the benefit of that phytochemical will change if the food is altered. So carotenoids, right? That's that yellow, orange, or red color in fruits and vegetables, like the orange color in these carrots. Lycopene is the red color in tomatoes. In red cabbage, you can see that nice bright purple color there. That flavonoid is water soluble. It'll turn red in acid and blue in base, so you can actually extract that flavonoid and use it in an experiment to test for acid or base properties of different solutions. Some canned foods have a white coating on the inside of the can, and this helps reduce color changes. So flavonoids can react with the metal in the can, so if it's coated, it'll prevent that change. Tea, the type of water used affects the cloudiness of tea. So if the water has calcium or magnesium dissolved in it, this will react with the flavonoids. A white and pale yellow color. This is in potatoes and apples, and they will keep a whiter color if the pH is 6 or below, and a more yellow if the pH is over 8. If you want to maintain the food flavors, okay, allyl sulfides have flavor compounds that are actually released when they're chopped. So if you've ever worked with garlic or onion, particularly onions, you know that there's a compound coming out of that because it often reacts with our eyes and makes you tear up. So this is a pretty strong flavor compound that's coming out when you chop it. But then when you cook the onion and the garlic, it makes the flavor milder. Isothiocyanates are unstable in heat. A stronger flavor actually comes out when these foods are cooked. So if you've ever cooked with a Brussels sprout, cabbage, or turnip, it's a pretty strong smell as those vegetables are being cooked. Polyphenols. This produces an astringency in foods, which will draw up the muscles of your mouth. Tea, grape juice, and wine are examples of this. But if you add milk to tea, for example, that'll reduce the astringency because the milk protein binds to the tea's polyphenols. Tannins. These are polyphenols that cloud liquids and can form sediment in beer or apple juice, for example. Now, what manufacturers will do is they will add gelatin, which binds with the polyphenol and then is filtered out of the system for a clearer juice.